Hello everyone and welcome to the talk. Today I'm going to talk about how to have visibility and security of CI/CD ecosystem. From the agenda perspective, first I'm going to set the context that why I'm having this talk at the first place. I'm going to touch upon the attack surface around the technology part and what could be the possible methodology we can have to address the challenge. And then I'm going to introduce an open source project, CICDGUARD, around the similar solution. And then we are going to deep dive into the architecture and the workflow, how the different components of that solution works. And we'll have a demo, and then I'm going to close out with the future roadmap around the talk. A bit about myself. I'm Pramod Rana, working as the application security manager with the Netscope. For those who don't know us, please visit it. We are at InsomniHack. And I'm primarily in two domains, security testing and DevSecOps. I'm author of 3 open source projects, Omniscient, vPrioritizer, and SecDependEdder, which I have presented in different talks, Black Hat, DEF CON, NullCon, last month, OS Global AppSec. I'm also OS Pune chapter lead and an OSCP. First, about the context. So let me start with the oversimplified version of the CI/CD ecosystem. So for any software in the world, we have a certain code base. That code base is stored in a central location in terms of organization. And then we have a solution which converts that code base into a deployable entity, which is again stored in a central location. And then we have a solution which deploys that deployable entity into the different infrastructure or the environment. And that environment could be anything. As a DevSecOps advocate, I highly recommend to have the security integration with each phases of the SDLC, which we call it security in CI/CD, as we all know it. It's a great topic, but this talk is not about that. This talk is about the securing the building blocks of the CI/CD ecosystem, which is security of CI/CD. In any kind of ecosystem, I'm using the word ecosystem very precisely here simply because no component or no technology in the overall CI/CD platform is independent. All of the things are related to each other because end of the day, as a software provider, we are delivering a software to our customer. And in any ecosystem, in nature as well, if we have a compromise of one component, it eventually impacts the entire ecosystem. And that is the need where we need to look at each component separately, but at the same time building the overall relationship between them. That is the part of problem. The first is the visibility part. And when I say visibility, what I mean by that is in a medium to large size of organization, as a security professional, I might be aware I have, let's say, 1,000 repositories, but do we have the visibility that how many third-party GitHub actions we are using across those 1,000 repositories? And even in best case scenario, let's say we have that visibility, but are we aware that which version of the third-party GitHub actions we are using across the entire organization? And that just one example of that. Another example could be, I might be aware that I have, let's say, 50 Jenkins server in my environment, but do I know that how many jobs are running on those 100 Jenkins servers? And if yes, that how many nodes I have across those different Jenkins infrastructure? So that comes the visibility part of the entire ecosystem. The other part is the relationship. Like I said, there is no independent entity when it comes to the CI/CD pipeline. All of those things are related. But how do we know the relationship between the different components which is flowing from A to B at any given point of time? And that we will touch upon the attack surface part as well. So let's say we have a Jenkins server which is running a job, building the binary solution which we are deploying at our customer site. So, and in that Jenkins server, let's say we have a very trivial vulnerability, default or weak credentials. So at first point, it might look like a very trivial vulnerability, but if we look at the overall picture, and that's where the relationship part comes into the overall system. from a very trivial vulnerability, which is a default and weak credentials, we will be impacting a binary, which we again is deploying into all of our customer infrastructure. And if you look at from the business perspective, that's I'll say one of the worst scenarios we could be in terms of security. Another area could be, let's say, in a GitHub action, we are running self-hosted runners, and that self-hosted runners is running a vulnerable or malicious third-party action. So what's going to happen is, I was looking at one of the talks where the presenter explained that how the mining or the cryptocurrency solution runs from these kind of scenarios where they will be using the organizational self-hosted runner in order to run the malicious third party into the environment. And I think that connects to the overall software supply chain security part. Another example of could be, as we all know that in the organizational level, we run on the SSO mode where the one user is presented across the different technology. And if by any means the user is compromised in one of the technology, it's eventually going to impact the other technologies as well. And let's say our GitHub as an enterprise doesn't support, it doesn't impose the MFA challenge. And then another scenario could be that the attacker were able to compromise the GitHub accounts with the social engineering. And if the GitHub account is compromised of the developer, it can further propagate to other scenarios as well. So this is the attack surface when it comes to the overall CI/CD ecosystem of the solution. And if we look at the methodology part, I think there are three parts to it when we are building a methodology. First is focusing on making the software secure and robust by default. And what I mean by that is, in any software, there are two phases. The one is of the software provider, and the other one is the software consumer. As a software provider, I think industry is doing a reasonably good job because of security in CICD, again looping back. But I think everyone has a responsibility as a software consumer as well. Whenever we are consuming a software, it's our kind of obligation to make sure that we are doing a basic security checks on that software. It could be an open source software. Let's say a very simple library you are using for a very specific job in your software, or it could be an enterprise product which is getting used by all the employees in your organization. And for that, what could be done is that having a vetting process, as simple as that, having a vetting process on an organizational level, that whenever you are using a certain software component which is not developed by you, are you making sure that you're looking at it from the security perspective? At the same time, when we find something in someone else's software, are we making sure that we are considering it on a whole community level, working proactively with the provider to fix that part? If we combine these two steps, where we are working to making sure that we, as a software provider, we are doing our best job to provide the software, but at the same time, as a consumer, we are sharing the responsibility of making that software secure. The second aspect, or the second part of the methodology, is how well we are implementing it into our environment. And that will vary as per the organization, because no software is secure with misconfiguration. Any software which is secure by default, if you implement it in a insecure way, it's eventually going to be insecure software. It could be as small as default settings disabled, MFA enabled, up-to-date plugins, apps, actions. Any enterprise level software as of today supports customization one way or other. For example, for Jenkins, it is plugins. For GitHub, it is actions. If you are using those third-party components within your organization, then you have to make sure that the security of those components, those custom components, is also considered. Third part of it is the monitoring, or the continuous monitoring part, where first we are monitoring whether anything bad happened. Are we able to detect it? Second, can we respond effectively if something bad happens? So these are the three, I'll say, aspects when we need to look at when we are building a methodology for the CI/CD securing of the CI/CD ecosystem in the organization. First, making sure we are taking a shared responsibility to make the software secure. Second, when we are using it with the, I'll say, adequate security controls. Third is we are monitoring continuously and have the ability to respond to anything bad happens. Now, this is where the open source software, the open source project comes into the picture, CICDGUARD. It does, first, it represents all the components into the graph forms. And what I mean by that is that all the different components of the technology will be break down into the node level, and the relationship, the edges between the nodes will show the relationship, how the different component is connected. What it helps is, it helps to get the visibility part correct. For example, it will just not show that you have 10 Jenkins server. It will even break down to the level of the jobs. It will say you have 5 jobs. So basically you will have 5 nodes, and then in which node those jobs are running. So you will have a relationship between the node of type job to the node of the type node. So that's how the overall graph picture is built. Why I used graph? Because personally, I think it's more intuitive when building the relationship database, relationship schema for the different technologies. And second thing is it goes to the granular level of breaking down the technology. Second thing it does, the security aspect, obviously, it tries to identify the misconfiguration into the different technologies, whatever it is finding at that moment, and provides the possible recommendation for that. Third thing, which is most important in my opinion, it tries to identify the relationship between the different components. Like I said, one of the challenges is finding the visibility and the relationship. So it handles that part by building the relationship, and that is the primary reason of using the graph theory, because graph theory is more intuitive for the relationship part. For example, if there is a certain change in a certain repository, how eventually it is going to trigger the certain build process in a different technology. So from the visualization perspective, how it's going to work out is that you have a node of type repository, and there is a change, certain commit. It eventually will go to a certain Jenkins job, and that job will eventually create a certain binary in a different artifactory. So all of that relationship is going to flow through the graph in the solution. And another aspect could be, like I touched upon for the GitHub action part. For example, in the organization, as per the process, we might say that whenever we are using a third-party GitHub action, we are going to have a security review of that. And depending on the security review, we are going to, approve a certain version of the third-party library, which we will say at that point of time that it is the most secure to be used in a security professional opinion. What it will help to identify is that in the organization, in the overall organization, what are the different version of any particular third-party GitHub actions you are using. And then we can map it back to the approved version, and we can identify any deviation we might have. So for example, at any given point of time for the GitHub action A, we are saying use the version 1. But in the organization, we are identifying the deviation of version 1, 2, 3. Then from the project, from the solution, we can identify, okay, these are the deviations, let's action on them. And do we have common users between the different technologies, so on and so forth. So first, the visibility part converts everything into the graph with the node, and the edge will represent the relationship. Then identifies the industry security misconfiguration in the technologies. And on top of that, it identifies the relationship between the different components. This is the node database schema. As you can see, I have break it down into the granular level possible. For example, for the GitHub action, it would be workflow, job, step, command, runner, action, so on and so forth. And interesting part, this I identified after building the solution, is that once you have a node of if you have a node with a similar schema already, then rather than creating a separate node, it eventually will make back a circular relationship to the node. So what happens with that is that, for example, if you have 5 runners in your organization, you can find the reverse relationship as well, that how many jobs are running in each of the runners. So for example, if at any point of time you feel that this particular runner is having too much load, then this tool can help you to identify that thing as well. So this is what the overall architecture looks like. It has, I'll say, 4 parts. First is the scan engine part, which runs independently. What this scan engine is, it's a collection of independent scripts in Python, and each script is designed to perform the security scan on a particular technology. At this point of time, it supports four technology, and you can use it independently. But at the same time, you can use it in the collaboration with the relationship as well. That is the scan engine part. The next part is the analysis engine, in which it tries to identify the relationship between the scanned technology. How it's going to work is, for example, you might run the script of Jenkins, and then you might run the script for GitHub. If you run the analysis engine on top of that, it's going to scan all the nodes for those two technology and try to identify the relationship. The more technology you are going to scan, the more comprehensive relationship analysis is going to be, and you can just keep going on that process again and again. From the output perspective, to build the analysis, all the database, all the information gets fed back to the Neo4j. Neo4j is the database, and you also have a JSON format in which case you want to, let's say, feed it back to the other technology, for example, Elasticsearch and all. In that case, what you can do is you can simply run the script, feed it back the JSON output into your choice of analysis engine you want. It also have a very basic web UI in order to visualize all the data and put some custom filtering on that. And all of this can be accessed by the user at any different point of time. In order to run the scan engine, there are 2 ways you can provide the inputs. The one is the environmental variables. You just set it there if you don't want to pass it into the command line, because all of this information will be secrets. And then other option is obviously the command line. And from the what kind of input it needs is the authentication detail to the respective technology you want to target, and obviously it will vary technology which kind of authentication information you will be providing. For example, in case of GitHub, you need the personal access token and all that. Depending on the privileges you are providing, it will able to read more and more information. In generally, since we will be accessing the script will be accessing everything, you will need to provide the admin access personal token in that. Any question before we go to the demo? Okay. I recorded demo for one very specific purposes, because in this demo, we have some information which I simply cannot show, so I have redacted it. That's why I have recorded this demo. But tool is so as you can see, there are 4 technologies in a certain directory, and you can run it independently. For the demo purposes, I'm using the environmental variable in order to provide the authentication detail, and no further information, no further input is required for in case of action. You can simply run it. Once it starts running, it provides the basic information in the command line about the running and all. So this you can run independent of the tool. You can simply go to the GitHub, do the clone, and start running. It's as simple as that. And every vulnerability, every security misconfiguration identified by the tool will have a certain identifier, and depending on the technology. As you can see, all of the output is in the JSON, so that it is readable by other analysis tools as well. This I ran for the GitHub action. So this is what the feeding part of the solution is, where you are running independent scripts. Again, now we are going to run the Jenkins. same process. You need to provide the authentication detail. It will build the connection, will try to fetch the information. It takes time, sometime depending on the network access and all. So as you can see, for example, JNK003, it's a identifier for the vulnerability it identified at that point of time for that. So all the information displayed in a square bracket is the redirected one. When you will be providing this information in the actual life, it will be displayed in that way. So as I told, it goes to the level of job, and then in the job, it identifies the node. It also identifies the plugins, what is the version of the plugins you are using, how those plugins are connected to the other Jenkins, other technology. It identifies the users, it identifies the groups, so on and so forth. I did not want to fast forward it intentionally because I wanted to give the actual feel of how the script is going to run out when in the actual life. Again, all the output is in JSON format in the command line, and then you can change it as per your need. So this is what the UI part looks like. Like I said, it's a very lightweight web UI at this point of time. We have different node colors in order to identify for the different technology. And as you can see, there are there are edges between the different technologies as well. Because I have in my demo, I have scanned almost all four technologies supported by the scripts, and because of that, there are a lot of data processed by that. That's the reason I have a filter where you can simply select the plugins part, and in the UI it will display the details about the UI. The red represents that the security vulnerabilities has been identified for that particular node. The relationship of the filter is OR. So basically it will say that select the node with the type plugin or type build. You can add and remove. One important part I wanted to make a visibility point here is that, so this light bluish color is the Jenkins build node, and it is getting connected to the repository within the GitHub environment. As you can see, this node is the type repository, and this node is of type build. What it implies that is this particular build is getting triggered by this particular repository, and if there is any change in the repository, it eventually is going to impact that build. So this is what I meant when I said the relationship between the different technologies, and it identified two different variations of that when I ran the scan in the demo environment. So this is the GitHub repositories, and this is what the Jenkins build is built. So if we are able to work on the so as part of the next step, I am working on building a overall path. At this point of time, it's a one-to-one relationship between the repositories and the build, for example. But from a visualization perspective, if we make the filter correctly, what we can do is we can make a connection back to the, let's say, user A made this commit on repository B, and repository B eventually triggered the build C. And that build C, like I said, goes back to the artifact A. So that's how we can build the relationship. At this point of time, from a filtering perspective, it just displays the one particular path. So going forward, Obviously, the first part is the expansion on the technologies more. Like I said, the more technology solution will cover, the better relationship it will be able to build. These are the few I have in pipeline. If you have any feedback, feel free to open a issue or the pull request into the repository, and then we can take it from there. I think, but my personal focus is on the analysis part. The more technology we build, the more type of nodes we will have. And what I mean by that is that more analysis we have to build. The primary reason of making this project was to build on the analysis engine more, which means that parsing of the different components more and try to identify the relationship between them as well. For example, it could be, if we consider any software-based organization, let's go with the microservice architecture where multiple repositories are responsible for building one service. Can we find that relationship that service S is built by 5 different repositories? So if we are able to build that kind of relationship, we will eventually be able to connect that which users change triggered which change in the service, in the microservice architecture. Can we build a relation on the contributing to a particular microservice and all? And second part is obviously the next part is the build the intuitive visualization, which include making the search engine more effective. For example, all the metadata. Can we make a search engine on the basis of the all metadata? So these are the parts on the going forward way. Like I said, first of all, thank you for being here. And if you want to know more about the Netscope and the product in general, please feel free to reach out.
So thank you for the talk. Any questions? Yeah. Can you pass the mic?
Hey, thanks for the talk. So you said the project is open source, but the repository is actually empty right now?
Yeah. I'm going to put the code after the talk.
Okay, cool. And so my question is, like, how many or how different or what kind of detections do you have there? Because like that's probably the main point of the tool, right?
What do you mean, the technologies?
No, like what kind of vulnerabilities do you detect there?
Oh, okay. So in terms of in terms of category of vulnerability, like there are different components. The first, I'm trying to identify whether there are any basic insecure configuration, for example, default credentials, HTTPS enabled or not. What kind of users are there in the system, and it will vary from technologies to technology as well. For example, in case of GitHub Action, one of the finding is are you using any well-known vulnerable version of the third-party software? In case of Jenkins, for example, it could be like, are you using vulnerable version of plugins or outdated version of plugins? In case of GitHub, it will be, for example, do you have MF enabled or not? So because so that is the library of the vulnerabilities I have in terms of each technologies. And with my tool, I'm going to also publish kind of knowledge base that which kind of vulnerability I'm detecting in a tool, irrespective whether it got detected or not. Make sense?
Yeah. Okay. Thanks.
Any other question? Was I that good or that bad?
You were that good.
Oh, thanks.
Good. But I have a question. What I really didn't get is, where do you get the information? Are you looking at config files that are local, or are you a super user who has access to all these tools?
This solution is super user who has access to all the information.
So
basically, it's an API call to the target technologies.
So before that, we had individual components talking to each other, like in a limited environment, and now we're getting a super user who has access to everything.
No. In the architecture, I had the breakdown into, let's say, broadly 2 parts. The one is the scan engine part. The second part is the analysis. Scan engine is again can be used independently. So how it's going to work out in practical life is that you identify which technology you are using in your environment from the supported technology in the solution. For example, you might say I'm using GitHub and I'm using Jenkins. I'm not using, let's say, JFrog at all. So you are going to configure those two scanners with the super user access for both. And then what it is going to do is it's going to scan the independent technology. It's going to fetch all the information. And then the analysis engine is going to make the relationship from the database, from the local database of the solution. Make sense?
Yeah, makes sense.
Other questions? Okay. Oh, perfect.
Thank you for the talk first. Yep. Is it possible to push those data into RDF database and not just graph?
I'm sorry, I did not get
Is
your
it
question.
possible to put it into ontologies and not just Neo4j graph database?
In terms of database, it's going to put in Neo4j. What customization you can do is, since in the command line I have all the output in the JSON, you can redirect that JSON output into your choice of technology. But on the fly, it's not going to. It doesn't support anything else at this moment.
Thank you.
Yeah.
Other questions? Okay. So
Good.
Thank you again for the talk.
Thank you. Thank you, everyone. Have a nice day.